we need to sort of remember a little bit about what happens with inverses. What can you tell me about inverse functions? Like if we took an ordered pair, if we said a function is, let's say, the set 3, 2, and 1, 4, what can you tell me about its inverse? The x's and y's switch, right? I mean, that's the fundamental thing about inverses. Their x's and y's switch. So if we were to look at the tangent, the regular tangent curve, now, there's not a lot to it in terms of points, because all we've done the origin, and then we have, you know, put in the asymptotes, but we haven't really plotted a bunch of other points. But what's going to happen if I take those points and turn them around? Well, instead of there being an asymptote where x equals pi over 2, now there's going to be an asymptote where y equals pi over 2. And y equals negative pi over 2. Remember, what was an x becomes a y. That's what happens with inverses. So if the asymptote was where x equals pi over 2, it's now going to be where y equals pi over 2. Now the only point I actually have plotted is the origin, and when I switch that, it stays the origin, right? But let's just kind of make up the coordinates of a point. That looks like it might be, what, 1, 2 or something like that. So that would become 2, 1. So that would come out here somewhere. There's a picture of your inverse tangent. Okay? So nothing tricky or hard or fancy about that. It certainly is not a point of emphasis. You know, it's not something I want you losing sleep about or sweating about or memorizing or anything else. The big picture is, how do we find inverses? What's the relationship between an original and its inverse? Just switch the x's and y's. So if you are comfortable with the original, just switch all the x's and y's. Okay? And who else? Good question. Who else found something anywhere on the review sheet that you had a question about? Maggie?
The word problem for 3.
Oh, number 20, the word problem number 3. Okay, so here we are at port, and the ship is sailing on a course due north. So you know what that means. Here he goes, due north. And he's sailing at a speed of 12 knots for 2 hours. So that means this length is 24. Okay, now he's here, but he's going to, this is where he started, now he's here, now we're going to change direction. Due west at a speed of 13 knots for 1 hour. So here he goes, due west. How long is this? 13. At this point, what is its distance and direction from port? So he's here now, here's port. We want to know his distance and we want to know his direction. That is not a bad problem at all, because what kind of triangle is that? We don't even need to figure it out. That triangle is a right triangle. If you went from due north to due west, that's a right triangle. So how are you going to find this length? The Pythagorean theorem. So whatever 24 squared was. 27.29 nautical miles. That's how far he is from port. Now, what's his direction? Well, wouldn't it be grand if I had that angle? Because in navigational land, we measure from due north, right? So how cool. Let's just find that angle. How would I find that angle? I would use tangent. The tangent of that angle equals 13/24. So second tangent, right? That's how I find an angle. I'll second tangent. And I got 28.44 degrees. Now, caution. If you say the answer is 28.44 degrees, you will be wrong. Why? It's in the wrong direction, right? We need this angle. Unless we want to say, remember this one, we haven't talked much about it, but we did that one day. North, 28.44 degrees west. Would that take care of it for me? So if I wanted to go ahead and use a combination of letters and numbers, I could say head north and veer 28.44 degrees to the west. Or I could name this angle, which would be what? What would this angle be? 360 minus that?
331.56.
So 331.56, did I subtract right?
Yeah.
So either one of those would be acceptable answers. 28.44 is not an acceptable answer all by itself. Okay. Anybody else find one? Delaney?
The second word problem.
The second word problem. Okay, so she is walking toward this building. Here's the building. And she's walking toward the building. At one point, her angle of elevation to the top of the building is 11 degrees. After 15 more minutes of walking, so she's walked toward the building some more, now the angle of elevation is 13.5 degrees. And I don't know how long that is, but I know that's 15 minutes. How tall is the building? Okay, now wait a minute. What are you doing, Annabelle? Hey, your dad and I hang out together 3 mornings a week. You better, toe the line. Okay. I don't know any lengths in this problem at all. I know no lengths. Somehow I got to figure out a length. Can anybody see a way to do that? Anna, you're nodding your head. What? Do you see a way to do that? I think I'm definitely going to be using tangent, but I can't do tangent until I figure, I don't know anything about any of the actual lengths anywhere in this picture. I need to somehow use this to figure something out from that. How could that help me?
Miles per hour.
Okay, now wait a minute. She is walking, I know her speed, right? Her speed is 3 miles an hour. This is a quarter of an hour. So how far has she walked in that 15 minutes? Okay, now wait a minute. Distance equals rate times time, people. Right? She's walking 3 miles an hour, and we let her go for a quarter of an hour. How far has she walked? 3/4. So this is 3/4, I'll say 0.75 miles, right? Now we had one exactly like this in our homework a couple days ago. We cannot solve this without setting up 2 equations. So that's what I'm ultimately looking for, but this is unknown to me, this thing right here, so I'm just gonna call it y. And I'm gonna do what Anna said, and I'm gonna write an equation that says the tangent of 13.5 equals x over y. Would you agree with that? Not solvable, but true. Then I'll look at the big picture and say what? What's an equation that's gonna come out of the big triangle?
Tangent 11 equals x.
Is that okay with everybody? Now, what do I do? What's my strategy now that I've got two equations set up? I'm gonna either substitute or eliminate, and usually substitution with these works better. So you can do that however you want. I think when we did this together, did we solve them both for x and set them equal to each other?
Yeah.
But one of the other classes, they just solved the top one and then stuck it in here. It doesn't matter. Ultimately, you're going to do the same amount of work and you're going to come out with the same answer. You have to do whatever makes sense to you. So I've solved the top one for x. This is what x equals. So now I'm going to take my bottom equation and I'm just going to put that in. So I have y tan 13.5 over 0.75 plus y. Does that make sense to you? Do you see what I did? Okay, what do I do now? Get this over here. Now that's going to be a distribute. So 0.75 tan 11 plus y tan 11 equals y tan 13.5. Okay? Now what? Get the y's on the same side, because your job is to get y by itself. So you got to get them on the same side, because once you get them on the same side, what are you going to do with them? We're not going to divide yet. First you have to factor. First you have to take the y out so that you can divide by the parentheses. So y will end up equaling 0.75 tan 11 divided by tan 13.5 minus tan 11. Okay, so I'll go to my calculator and I'm going to very carefully type that in. Anytime there's more than one thing in the denominator, make sure it's in parentheses, and then don't forget to close all the parentheses that your calculator puts in for you. Sometimes we forget about that. I got 3.19. Anybody want to confirm that for me? Am I the only one typing this in?
Very disrespectful.
Sorry.
I think that's a yes.
Okay.
Okay, caution, y is not what I'm looking for. I am looking for x. So I'll come up here and say, okay, I now know what y is. So all I have to do is take that number times the tangent of 13.5, and I get 0.76. Actually, 0.77.
So it's like substitution.
Now, what's the unit on that? That would be miles. That's 0.77 miles. Because the only length we had was in miles. Okay, we got time for one more. Anybody else? So which you just did. Well, normally when someone says how tall is a building, I don't answer that in miles. So this came out in miles, so if I just take that times 5,280 feet, I'll know how many feet it is. That would be the normal way of answering it. The fifth word problem says find the area of the shaded, find the area of the shaded region. Now, the area of the shaded region. We talked about this the other day. What would be the area of the whole circle? $36 pi, because the area of the whole circle is pi r squared. Now, what if I wanted half the circle? You would just multiply that by a half, right? If I wanted a fourth of the circle, you would just multiply it by a fourth. Well, what fraction of the circle do I want? Now, if you do 95 over 360, that's okay, but that isn't actually what you want. That would be this, right?
Yes.
So then you could take that, or you could subtract 36 pi minus that, or you could just skip all that and get, well, what fraction do I want? If this is 95, what's this? 265? So could I just take 265 3/60ths of the area? And instead of taking half of it or a fourth of it, I'm going to take 265 over 3/60ths of it. Madeline, what are you doing? Now, what you suggested, Heidi, is absolutely fine. If you want to do 95 3/60ths and then subtract it from 36 pi, that will work every time also. Not an issue. Okay, Delaney?
Yeah, and then you just multiply and
Yep.
cancel.
Well, these are going to cancel, actually. So this is just going to be 10 down here. So what if you can take a 5 out of both of those and reduce that fraction. Okay, for Tuesday, if you have not finished last night's review sheet, you need to do that. And in addition, you need to do the sheet that is called pre-test. Now let's do the right sheet. We also have one called practice test. That's not your homework. Your homework is the one called pre-test. Okay? And it's shorter. It's a shorter one, but it has a lot of the same kind of problems on it. So when you come to class on Tuesday, what should be done? Pre-test and review sheet. And I will actually be here at the beginning of the period on Tuesday, so what might I do? I might check it, get it done. Oh, it's Friday. Oh,
Whatever you
Friday hard time.
I don't